Okay, so today we are going to look at simultaneous equations on the XY factor. Okay, so simultaneous equations are a form of linear equations. We'll come back a little bit more to what they are in a moment. But up to now, we've looked at linear equations that look something like this, or we might have simplified them to be something like this. And in order to get x on its own, well, we'd have added on x here, which means I'd have added on x here. And that would have given me, say, for example, 3x plus 3 is equal to 7, and those two x's would have cancelled. And so here I would take away 3, so I would also take away 3 here. That would cancel the two 3's there, and I'd have 3x is equal to, well, 7 minus 3 is 4. And so in order to get x on its own, I would have said something along the lines of, well, 3x, here I would divide by 3. So if I divide by 3 on this side, I must also divide by 3 on the other side. And so then I would get x is equal to 4 over 3. And that would have been my answer. So they're the kind of linear equations that we've looked at up to now. So this gives us a value for x. But we know, now we haven't done graphing yet, but we're well aware that if, we look at graphs, we have an axis, two axes in fact, an x-axis and a y-axis. So this information here, the x equal to 4 over 3, well, that's, if here is 0 there, and here is 1, and here is 2, now we'd also be using rulers for that, well then I know that 4 over 3 is somewhere around here, because it's 1 1/3, okay? So that's all that's telling me. But I could use also that information if I had an equation where I have an x and a y, two variables, so we'd call that a line, a linear equation. That tells me when x is 4 over 3, y is something else. And so those equations might look something along the lines of y is equal to 3x plus 4, for example. Okay, so we're going to look at a couple of others now. Okay, so here we're given a linear equation which is y equal to 2x plus 5. And if we were to graph that, well, here, this letter here, you'll remember from last year, means that the slope is 2, which means that here the gradient, so it looks at the slope of the line. And the 5 shows where it crosses the y-axis. So it says, well, if x equals to 0, y is equal to 5, which we could figure out by substitution. So that's how it would represent graphically. But we can rewrite this equation. We could move the x over to this side, and if we were to do that, well, then I'd take the 2x from that side. So I would take 2x from this side, which would mean my equation would look like this. Minus 2x plus y is equal to 5, because the two x's here would cancel. I could also rewrite the equation as minus 2x plus y, and here I could have minus 5, so here I'd also have minus 5, and so that would give me minus 5 here is equal to, well, 5 take away 5 is 0. So there are the three different ways that we could write linear equations. Now we're going to concentrate on this kind of form of a linear equation, where basically we have an x term, a y term, and a constant. And for simultaneous equations, if we have two of these together, where they're equal is the point of intersection of two lines on a graph. Okay, so we'll see here. So here, for example, we have a picture of a graph, and here the point of intersection is where these two cross. So an example of a question involving a simultaneous equation is these two here. So it's asking us to solve for x and y. So we have 5x minus 3y equals 7. So we need to rearrange this one so that it looks like this format, that you have your x term, your y term, and a constant. Okay? And basically our solution, our x and y solution, is that point of intersection. Okay, so let's look at this example in further detail. So as I said, step 1 is to rewrite so that both have an x term, the y term, and an equal sign, and then the constant. Okay, so here we have to rearrange this one. So rearrange. So first of all, well, I have my x term on the right side. So I have 2x is equal to y. Now I'm going to add the 3 here to get rid of it there. So I'm going to add the 3 here, which means I have 2x is equal to y plus 3. Now I still want the y over to the other side. So here I need to take away y. So here I need to take away y. So I have 2x minus y is equal to 3. So this one I'm going to label equation 1 and this one equation 2. Okay, so that's the first thing, just to rearrange the terms into the correct format. So now we'll go and we will solve, and we'll solve using a thing called the elimination method. Okay, so here I have both my equations rewritten in the way that we did on the last slide. So 5x minus 3y is equal to 7, 2x minus y equal to 3. And the elimination method, well, that means I want to eliminate, I want to get rid of one of the variables. Okay, so we're going to have a quick look here and see which one could I get rid of. Now the only way I can get rid of those is if they're the same number, and then we take the equations away from each other. So I want the coefficient here for the x's to be the same, or the coefficient for the y's to be the same. Now I can see in this example they're both different. But if I was just to multiply across by 3 here, I would have 3y, and then I'd have the coefficient the same thing. So that's what I'm going to do. I'm going to multiply by 3. Okay, so now I'm going to still have my first equation, 5x minus 3y is equal to 7. And now I'm going to have, well, 3 by 2x gives me 6x. So I'll have 6x. 3 by minus y gives me minus 3y. And 3 by 3 gives me 9. So that's equation 1 and equation 2. And now I'm just going to take those away from each other. So essentially I just change the signs. So here that becomes a plus and that becomes a minus. So I have 5x minus 6x, well, that gives me minus x. Minus 3y plus 3y, well, now I know they cancel. I have eliminated. Okay, so here I have my equals. So 7 take away 9, well, that gives me minus 2. And now I just want to make that positive. So x, if minus x equals minus 2, well then x equals 2. Okay, so that is one solution. And so now that I have my solution for x equal 2, I now go back and I write down, say, equation 1, 5x minus 3y equal to 7. And I use that x equal to 2 in order to get a value for y. So here I'm going to have 5, and instead of x, I'm now going to write down 2. Minus 3y is equal to 7. 5 by 2, well, that gives me 10. Minus 3y is equal to 7. And just going over here. Again, I want to get rid of the 10 on this side, so that's minus 10 here, which means minus 10 here. So I'm going to have minus 3y is equal to, well, 7 take away 10 is minus 3. And so now just to get y on its own, y is equal to minus 3 divided by this minus 3 here. So minus 3 divided by minus 3, y is equal to 1. So essentially, the point where both of these lines will cross each other is at x equal to 2, y equal to 1. And so just to write that a little bit tidier, we would write that x equal to 2, comma, y equal to 1, and put a box around it. Okay, we're going to do one more example. Okay, so here our example says solve for x and y. So I have x plus y equals 4, x plus 7y equals 10. Now I very quickly, you can see my coefficients of x are the same. So I could straight away just take one equation away from the other. However, on this occasion, I'm going to just stick with getting rid of the y's because that's what I did the last time. So to get my y coefficients the same here, well, what do I want to do? I want to multiply equation 1, I want to multiply it by 7. So here, when I rewrite equation 1, I'm going to have 7x plus 7y is equal to, well, 4 by 7 is 28. Here, I rewrite equation 2 as it was, x plus 7y is equal to 10. I draw my line, and now again I take the equations away from each other, and minus. So here I have, well, 7x take away x, that leaves me with 6x. And here, 7y take away 7y, well, that leaves me with, they cancel. And so here I have 28 take away 10, and that's going to leave me with 18. So I know then, well, x is equal to 18 divided by 6, x is equal to 3. And again, similarly to the last example, we now use our solution for x to give us an answer for y. Okay, so again, I can take either equation. So I'm going to take the first one again. X plus y is equal to 4. Now I know my answer for x equals 3. So that's what I'm going to substitute in here. I have 3 plus y equals 4. So again, to get y on its own, well, I'm going to take away 3 here, which means I take away 3. They cancel, and y is equal to, well, 4 minus 3 is 1. And so that's my answer for y. And so I just rewrite here x equal to 3, y equal to 1. Okay, so make sure you have both examples taken down in your copy, and then pause the video and you can do the learning check, which just will appear in the next slide. Okay, so for the learning check this evening, just solve for x and y. So x minus y equal to minus 2, x plus 9y is equal to 8. And just a little clue here, again, stick with the same of getting the coefficient for y to be the same. So I'd multiply across here by, you can decide. And here, because these signs are opposite, you'll just have to add the equations this time, rather than take them away. Okay, so give it a shot.